All right, welcome back to properties of integrals. Last video was starting to run a little bit long. I'm trying to keep them under 10. If I can, I'm trying to keep them even less than that. So I decided to do some examples of the properties in a new video instead of continuing. So the first example we're going to look at, we're going to be given some integrals. The integral from -1 to 1 of f of x dx is equal to 5. The integral from 1 to 4 of f of x dx, notice same function, different interval. And then the integral from -1 to 1 of h of x, different function, is equal to 7. So the question becomes, can we figure out the integral from 4 to 1 of f of x dx? And what we notice is that it is just the opposite of this, and so the answer to this one is just going to be 2, the negative of -2. Second example, what about the integral from -1 to +4 of f of x dx? Well, what we notice is that the first goes from -1 to 1, the second goes from 1 to 4. So we can find from -1 to 4 by adding these two together. And of course, that makes this equal to 3. All right. What about the integral from -1 to 1 of 2f of x plus 3h of x dx? Well, splitting this up, the sum rule says we can split that into two separate integrals. The constant rule says take the constant out front. So this is twice f of x plus 3 times h of x. And notice that this only works because the limits of integration are the same on both functions. If they were different limits of integration, you would not be able to do this. So now I've got 2 5s plus 3 7s giving me 31. All right. So there's a bit of an idea of the kinds of things you can do with those rules of integration. Let's look at another one, example 2, which is bounds of integrals. We're trying to find the integral from 0 to 1 of the square root of 1 plus cosine of x dx. And what we want to actually show is it's less than 3 halves. And this could be some kind of engineering problem whereby you want to make sure you're not going to go outside the bounds of some parameter. So let's look at the min-max. Well, the lower bound, let's just look at the square root of 1 plus cosine of x. This is f of x. And obviously the lowest this is ever going to go, oh, by the way, we're on the interval 0, 1. That's sort of important. The lowest this is ever going to go, yeah, I don't actually care about minimum. I'm trying to find a maximum. So the maximum this is ever going to go, we know that cosine of x is always less or equal to 1. So the max value of f in this case is square root of 2. So the integral from 0 to 1 of square root of 1 plus cosine x dx must be less than or equal to square root of 2 times the interval, which means it must be less than or equal to the square root of 2, which of course is approximately 1.41, which is in fact less than 3 halves. Graphically, if you wanted to look at this, what we see is that the cosine function from 0 to 1 looks something like this. The maximum value of this integral is, I don't know if I like that graph. Do I like that graph? Oh yes, yes. That's the limit we're interested in. And the maximum value of this integral, of course, is going to be equal to this right here, which is square root of 2. All right. So there's a couple quick examples on how to use those properties. And we'll stop right there and we'll be back with average value. Thanks for watching.